Welcome back. In this video, we're going to work a problem where we talk about marginal analysis, where we analyze the rate of change in selling one extra unit for the cost function as well as the revenue function. So this problem states an analyst has found that a company's costs, C of X, and revenues, R of X, in dollars for one product are given by these two functions. C of X equals 2X and R of X equals 6X minus X squared divided by 1,000. And in both of these situations, X represents the number of items produced. So if we know the number of items produced, we can determine our total cost. And if we know the number of items X produced, we can also determine our total revenue. So for step A, we want to find the marginal cost function. And we're actually going to find marginal cost, marginal revenue, and marginal profit. And what marginal means in this business application setting, it's the cost which is added by producing one additional unit of this product, or the revenue added by producing one additional unit. All right, so this means what is that change for one additional unit? That's what marginal means. And essentially, when you see that word marginal, what you want to remember to do is to find the derivative. So marginal is going to mean find that derivative, because the derivative is a rate of change. So let's focus on part A, and we'll find the derivative of C of X equals 2X. And in this problem, we just use the power rule, so C prime of X equals 2. So my marginal cost function is 2. All right, let's find the marginal revenue function. So B, we are given R of X equals 6X. I'm going to take that and write that as a coefficient, 1/1000th X squared. So it's all in understanding how to read the problem as well, which is going to make your life easier. So thinking about that's not going to be a quotient rule type situation. That's a coefficient. And when I go to calculate, I'll use my power rule on each of these terms. So the derivative of 6X is 6 by the power rule, and my coefficient 1/1000 remains. The derivative of X squared is 2X. And simplifying that, R prime of X, my marginal revenue function, is going to be 6 minus X over 500. For part C here, we're going to use the fact that profit is the difference of revenue and costs, or rather, we know that profit is your total revenue, all the money you take in, minus the cost, the money you had to spend to set up your operation. And the same goes for marginal profit and revenue and cost. So notice I'm adding my apostrophes in here to indicate these are all primes, or they represent derivatives. So in this situation, for problem C, we've got P prime of X. That's going to equal my revenue function, which is 6 minus X over 500, minus my cost function, which is 2. And of course, I can simplify this. So P prime of X, my marginal profit function, is negative X over 500, and 6 minus 2 is 4. So this tells me my rate of change in profit for adding an additional unit. So if we look at part D says, for what values of X will that marginal profit that we just found, marginal profit, equal to 0? So that means find your X value if you know P prime of X is equal to 0. So P prime of X equal to 0 is what we're doing for part D. And p prime of x, that's negative x over 500 plus 4 equals 0. Or moving that term over, 4 equals x over 500. And then cross multiplying, we have 2,000 equals x. 4 times 500 is 2,000. So what does x represent? If we scroll back up here and we remember what x represents, that's the number of items produced. So in order to answer this question, we'll say when 2,000 items are produced, the marginal profit is 0. And what that means is that there's no change in profit. If you're producing 2,000 items, the profit's not rising or falling, it would be remaining constant. All right, so our last part here, we're going to come in and focus on part E, which is find the profit when marginal profit is 0. So that means find the profit. Profit's an output when marginal profit is 0. When marginal profit is 0, that means x equals 2,000. So find the profit at x equals 2,000. Now again, I do not have a profit function given. I'm only given a cost and a revenue function, and I have found marginal cost, marginal revenue, and marginal profit. But in order for me to solve this last piece here, I need to determine that, again, remember, profit equals revenue minus cost. My profit function, P of x, is going to equal revenue was given is 6x minus x squared over 1,000 minus my cost function, which is 2x. So profit is equal to 4x minus x squared over 1,000. I combined like terms. 6x minus 2x was 4x. So now I just need to take that 2,000 and plug it in for x. So P of 2,000, my profit at 2,000 units is 4 times 2,000 minus 2,000 squared over 1,000. And that value, P of 2,000, is going to equal 2,000 equals 4,000. So that means the profit, we're not dealing with marginal, we're just dealing with profit. The profit at 2,000 items or units of whatever we are producing is $4,000. All right, and that is it for this problem. So the big takeaway here is when you see these word problems and they say marginal cost or marginal revenue or marginal profit, you need to take the derivative. Marginal means that rate of change, the change in the revenue, cost, or profit when you produce one additional unit. If you do have any questions, please feel free to email me, and I hope you have a great day.